So I have wired my breadboard to match my truth table over here for x1 and x2, labeled x1, x2. On my outputs, the white wire, this white wire right here represents x1. This one represents x2. And blue wire represents input A, going to switch A. Green wire represents switch 2, which is B. Brown wire represents C, which goes to switch 3, and then the orange wire goes to switch 4, represents D. I also use orange wire to connect one gate to another, for output one gate to into input into another gate. So for my truth table, it says that when B is 1 and C is 1, x1 and x2 are both 1. So we'll try that here. And right there, x1 and x2 light up. Same goes when B, C, and D are 1s, x1 and x2 are both 1s. So if we turn on the fourth one, D, they both stay on. If A and C are both 1s, x1 and x2 are also 1s. So if we turn off B and D, turn on A, x1 and x2 light up. If A and B are both on, x1 and x2 are also 1s. So A and B are both 1s, they're on. x1 and x2 are both on. If A, B, and C are 1, x1 and x2 are also on. And if all 4 of them are 1s, then x1 and x2 should be a 1, which they are. So in this truth table, x1 and x2 must be a 1, or x1 and x2 are always going to be 1s. There won't be a case where x1 is on and x2 is off. As you can see in the truth table, it says that when these inputs from these equations, B times C is 1, just like it is in these 4 right here. And when A, B prime, D prime is 1, A, C prime, D prime is 1, A, D prime is 1. And as you can see, these all match the breadboard.